Hello guys, in this video I will be discussing about the round robin algorithm for CPU scheduling. Okay, now in this algorithm we will be using the quantum. Okay, now the definition of quantum I have already told you in the first video of CPU scheduling, that is time slice allotted to each process for their execution. Okay, and that is fixed. Now let's see an example on the algorithm. So processes have been given and burst time has been given. Okay, so there are four processes: P1, P2, P3 and P4, and their burst times are 10, 3, 8 and 4, and the size of the quantum is Q equals to 5 milliseconds. Okay, so the fixed time slice allotted to each process is 5 milliseconds. So let's draw the Gantt chart. So Gantt chart. Now for P1, okay, for P1 we are getting 5 milliseconds. So from 0 to 5 P1 will execute. Now P1 has burst time 10. That means after the first slot P1 will still have 5 milliseconds left for execution. Okay, then we have P2. Now P2 will get 5 milliseconds. Okay, but it has burst time 3 milliseconds, so it will not utilize its 5 allotted milliseconds, but it will complete its execution in 3 milliseconds only. That means 2 milliseconds will be saved for P2. So it will take 3 milliseconds. That means it will complete its execution at 8 milliseconds. Then we have, so that means it has completed its execution. Then we have P3. P3 will also get 5 milliseconds, but it has burst time 8 milliseconds. So let me write P3 here, and this will be 13. Okay, so plus 5 plus 5 plus 5. Now after its allotted 5 milliseconds, it will have still 3 milliseconds left. Then we will go to P4. P4 has burst time 4 and it has been allotted 5 milliseconds. Okay, that is fixed. So it will complete its execution before that 5 allotted milliseconds, and it will have 1 milliseconds left. So P4 will complete its execution at 17. Okay, so P4 is completed. Then we will move on to P1, and P1 will complete its 5 milliseconds left that was left. So P1, this will be 22, and P1 is completed, and then we have only P3 left. So P3, that will complete its execution. Now all the processes have completed their execution. Okay, now let me explain it again. We have 4 processes and their respective burst times. Okay, and we have 5 milliseconds allotted to each of the process for their execution. Now P1 will come first. It will utilize its 5 milliseconds. Okay, and after that utilization it will still have 5 milliseconds left for execution. So we will leave that process there and we will move on to the next process, that is P2. P2 has burst time 3 milliseconds. Okay, so it will not utilize its 5 allotted milliseconds and will complete its execution at 3 milliseconds only. So after that we can move on to the next process, that is P3, which has burst time 8 milliseconds. So it will utilize completely its allotted 5 milliseconds, and then also it will have 3 milliseconds left for execution. So we will leave it there and move on to the next one, that is P4, which has burst time 4 milliseconds. So it will not utilize completely its allotted 5 milliseconds, and it will complete its execution before that allotted time. Okay, so after that we will move on to P1. So we are going like this, and again we are going to the top for checking whether any process is left or not, and that's why the name has been given as round robin algorithm. Okay, so we are going to P1, which has 5 milliseconds left, so it will complete its 5 milliseconds execution. Okay, and after that we will go to the last remaining process, that is P3, which has 3 milliseconds left, and we will allow its execution for 3 milliseconds. So this is the whole process. So plus 5. Okay, these are plus 5s. Okay, but in these cases there will be no plus 5 because they are completing their execution before that allotted time. Now we will calculate the average waiting time. Okay, now for P1 the waiting time is 0. Again P1 is getting the CPU at 17. So 17 minus 5. So 17 minus 5, that is equal to 12. Then we are going to P2. P2 is getting at 5. Okay, and only then it is completing its execution. So P2 is not dragged further. So P2's waiting time is 5. Then we have P3. P3 is getting the CPU at 8. So its first waiting time is 8. Then again it is getting at 22. So the second waiting time is 22 minus 13. That is equal to I think 17. Okay. So finally we have P4. P4 is getting its allotted time at 13 milliseconds. Okay. So the waiting time of P4 is 13. Therefore the average waiting time is, it is equal to 12 plus 5 plus 17 plus 13 divided by 4, which is equal to 11.75 milliseconds. So this is the round robin algorithm, and this was the last video on the CPU scheduling algorithms. From my next video I will be starting with the page replacement techniques. Okay, so stay tuned to my channel for the videos, and if you are new to this channel, please do subscribe, and if you like the video, please hit the like button, share them among your friends, and if you face any problem, then do let me know through the comment section. Thank you.